Okay, guys, I'm going to show you what to do to analyze a circuit that has a resistor in the main trunk. So for example, right here, you have a 3 ohm resistor in the main trunk, and you have these two 4 ohm and 2 ohm resistors in two parallel branches below the main trunk. All right. So it's really important when you listen to this or learn how to do this, don't try to memorize all the steps, because in the grand scheme of things, like if I were to write down all the steps you do to analyze this, you would have this list of steps that's like 25 steps long, and it's really difficult to memorize every single one of those steps. What's more important is you understand the idea of why you do each step, and then it becomes actually pretty easy to remember what the steps are, because you have a sense of like why it is you're doing certain things. All right. So please pay attention to not just like exactly what steps I'm doing, but the thinking behind why I'm doing certain steps. Okay. So let's review again, just from a voltage point of view, what this resistor in the main trunk does. So I've talked about this before pretty briefly, but I'll remind you again what this resistor in the main trunk does. So let me assign a voltage to this battery. Say that's 9 volts. Okay. Now, if this 3 ohm guy wasn't there, this 4 ohm and 2 ohm would both get 9 volts. So they'd be the same as each other, and they would both get the full battery voltage. The thing is, they're not going to get the full battery voltage anymore, not with this 3 ohm in the main trunk. All right. Because what's happening there, let me redraw this over here. What's happening there is that so these two guys are still going to get the same as each other. It's not going to be the same as the battery anymore, because this main trunk resistor is going to take some voltage away from what these two parallel branches are going to get. So in other words, this guy in the main trunk and this parallel are in series. And remember, when you have two objects in series, they're going to share the voltage from the battery. Right? So for example, this guy may take 5 volts, which means these guys have 4 volts left over. There's 4 volts left over for both of these guys. All right. Or it may not be 5 volts and 4 volts. Maybe this split is going to be, let's say it might be like 6 volts for this guy, in which case both of these are going to be 3 volts. All right. Or maybe it might be, say, like 2 volts for this guy, in which case both of these guys are going to get 7 volts and 7 volts. All right. So do you guys understand how these two, right, this parallel part, this resistor in the main trunk and this parallel section are splitting the 9 volts. Okay. So our first question that we need to find out then is, how are these two sharing voltage? How are these two circles sharing voltage? All right. How much voltage is this main trunk resistor getting? And therefore, how much is left over that both of the parallel branches are going to get? All right. Is it going to be 5, 4, and 4? Right. 5, 4, and 4, or is it going to be 6, 3, and 3, or is it going to be 2, 7, 7, or some other non-integer breakdown? Like, for example, this could be 5.5, and then this then be 3.5, 3.5, stuff like that. All right, that's your first question that you have to be able to answer. That's what I'm going to show you how you do now. Okay. So here is, I've redrawn the circuit here. Let me add in the battery voltage in here again. This is 9 volts. All right. So here's the first thing you need to do. I would highly recommend you redraw the circuit. Okay. So you have to understand this circuit. I'm going to redraw the circuit like this. Okay. Where this guy in the main trunk is this guy over here. And then this circle, this parallel section, is this guy right there. Okay. And remember, the entire point of redrawing this is to be able to find out what the voltage split between this circle and this circle is. So if we can find out how these two share the voltage, that'll tell us how these two shared the voltage in the original circuit. All right. So for example, if these two, hold on, let me redraw this as 9 volts. All right. If these two turn out to be, for example, 5 volts and 4 volts here, then you can apply that back to here. This is going to be 5 volts, and that's going to be 4 volts, 4 volts. Okay, right? So if this is 5 volts and that's 4 volts, this would be 5 volts, and that's 4 and 4. Or say, for example, if this turns out to be 6 and 3, then this is going to be 6, 3, 3. Okay, right? So once again, the entire point of redrawing the circuit like this second one I drew right here is to find out how these two share the voltage, okay? So how do you find out how these two share the voltage? Well, it depends on what these two resistors are, right? Because these two resistors are in series, and depending on their values, they're going to split up the 9 volts in a certain way, all right? And so it depends on what their resistor values are. So we just need to find out what these resistor values are. Well, that's pretty simple, because if this resistor right here represents this original resistor over here, then this resistor represents a 3 ohm resistor, okay? And this resistor right here represents these two combined into one. So this entire parallel section right here combined into one resistor is what this resistor represents. So you need to find out, well, how do these 4 and 2 combine into become 1? And your first thought might be, oh, well, the 4 and 2 combine to become 6, except that's not correct. Why? Because those 4 and 2 are in parallel with each other. Remember, in parallel, 4 and 2 do not combine to become 6. They combine to become something smaller than the smallest one. And how do you find the total resistance? Well, we had this fancy 1/R formula to find the total resistance, right? So for example, that 4 and 2 combine in a special way, and you have to use this 1/4 plus 1/2. All right. And once you do that, you can you can do fractions if you want. This is 1/4 plus 2/4. That becomes 3/4. Then don't forget to do one last flip. That's 4/3. Or if you want, I'm going to turn this into a decimal. That's about 1.33 repeating ohms. Okay. I'm just going to round that to 1.33 ohms. Okay, so that's 1.33 ohms. Okay. Now, understand then, why did we do this? Why did we redraw this? Once again, the big picture is you want to redraw this original circuit as a series circuit, because in series, that will allow you to tell you how this battery voltage gets split between the main trunk resistor and the parallel resistors. All right. So basically, if I combine the parallel part into one resistor here, 1.33 ohms. Now, from there, I'm going to do another picture then. Whoops. That's not what I wanted. Oh, here it is. Okay. So now from there, I'm at this point. Okay. So this is 9 volts. This is 3 ohms. Whoops. And this is 1.33 ohms, correct? Okay. Now from there, I just need to do a standard series analysis to find out how that 9 volts gets split between the 3 and the 1.33, right? So I'm just going to go through our standard steps. I equals V/R, right? This is a standard series analysis. So this is going to be 9 over the total resistance, which is 4.33. Well, this didn't record my handwriting very well. Okay, 4.33, which is, I don't actually have my calculator up, so let me get my calculator. Okay, so that's going to be 9 divided by 4.33, which is about 2.08 amps. All right. And then I can use that 2.08 amps. Good. This stylus is not working very well. Okay. I can use that 2.08 amps to find the voltage for each one. All right. So the voltage for the 3 ohm guy is going to be 2.08 times 3, which is 6.23, 6.23, let's just say 6 volts. All right. And the other guy is going to be 2.08 times 1.33, right? So the other guy is going to be the 2.08. Hold on, let me figure that out. 2.08 times 1.33, and it's going to be 2.764 about. Okay. Notice that, excuse me. Notice that these two voltages should add up to the 9 as we expected. All right. So what have we just found here? Okay. It's very important you understand why we just did all those steps. Okay. So what we just found here is that the voltage here is 6.236, right? Oh God, my pen. And this voltage is 2.764. Okay. So the entire point of redrawing the series circuit is to find these two voltages, which we just found. All right. So what are we going to do with these two voltages? Well, now I can then go back here and know those two voltages that we just found here are the same two voltages that will be applied right here. So for example, right here, this guy right here is 6.236 volts. Then I can go back here and see that this guy is going to get 6.236 volts. And if this guy right here got 2.764 volts, that means both of these parallel branches are going to get 2.764 volts. So this top guy is going to get 2.764. This bottom guy is going to get 2.764. So that means then I'm going to go ahead and start a new drawing then. Let me go back to black. Okay, so I can then go back to the original. All right, the original circuit, which is 3, 4, 2. Okay, and now I can apply those numbers that I just got from my last drawing. So I know that 3 ohm guy right here, I'll write that in red. The 3 ohm guy is going to get hold on, I forgot what I wrote. 6.236. All right, 6.236 volts. And these two right here, the 4 ohm and the 2 ohm guy, are both going to get, let me see, 2.764. So this guy's going to get 2.764 volts. And this guy's going to get 2.764 volts. Whoa, put my decimal point in the wrong place. Let me see if I can kind of erase some of that. Okay, so back again, 2.764 volts. Okay, so now I have the voltages for each ones. Now it's just time to find the currents. So how do I find the current in this top branch? Well, that's the same as the parallel steps we did before. To find the current through a parallel branch, use the voltage of that branch divided by the resistance of that branch. Now I know the voltage of that branch is 2.764. So I'm going to do 2.764 divided by the voltage, the resistance of that branch. That will give me the current for that branch, which looks like it's about 0.691 amps. Okay. And then I do the same thing for the bottom branch. 2.764 divided by 2 ohms is going to give me 1.382 amps. All right, so now I have the voltage and current for both of these guys. How do I find the current through this guy? Well, I should know how to do that because this guy's in the main trunk. And remember, how does the main trunk current compare to the branch currents? Well, it is the sum of the two branch currents. So if I add up these two branch currents right through here, right? So in through this main trunk, right through there, that current is going to be the addition of the two branch currents. It's going to be 0.691 plus 1.382. Okay. And I get 2.073. So that is how much current is flowing through this main trunk resistor in the entire main trunk. One of the things you may notice that this current you found in the main trunk here should be the same current, the same current that you found here, right? When you analyze the series circuit. It is pretty close. I'm a little bit off because I'm having some rounding issues where, I mean, by cutting off the decimal places, and I've been rounding and rounding. And so all of these numbers are actually maybe just a little bit off. So that's why this 2.073 and this 2.08 right here should have matched up. I having some rounding issues. I feel like I rounded too much somewhere in some of these things. All right. So hopefully my numbers are relatively close. If you got different numbers because you didn't round as much as I did, then that's fine. But just, I'm hoping you get the basic idea. Okay. So here I now have found the voltage and current for every resistor. And there you have it. Okay. And then from here, of course, then you can calculate power, V times I, V times I, V times I if you need to. Everything else is the same as before. Okay. So once again, let me do a quick step-by-step review of exactly how you do this. All right. First thing you do, you want to redraw this as a simple series circuit where you have the main trunk resistor and the parallel section. The parallel section should be combined into one resistor so that you have the main trunk resistor in series with the parallel section resistor. Okay. Remember to collapse the parallel system resistor into one, you have to use the parallel resistance formula. And as a review, you should always get something smaller than any of the individual branches here. Okay. So this guy right here is always going to be smaller than either of the parallel branches. Now, once you do that, you can then do a standard series analysis to find out the voltage split between these series guys. Okay. Once you find the voltage split between these series guys, you can then apply those voltages back to the original, where this main trunk guy gets the same main trunk as you found in the last slide. And then both of the parallel branches get the same as the equivalent parallel resistor here. And then from there, you can find the current in each branch by using branch voltage, branch resistance, branch voltage, branch resistance. And then you can find the current in the main trunk by adding together the two branches. Okay. So I'm hoping those steps make sense. Now what you want to do is work on the worksheet that I've also attached to Schoology that has main trunk resistors. Okay. I have the worksheet, we're going to work on it. And I also have the key to that also posted on Schoology. So try that out. See if you can get the right answers. If you're still having major troubles, even after watching this video, maybe you have to watch this video multiple times to actually fully understand it. But if you're still having trouble, go ahead and send me an email, or you can attend my office hours, which at the time I'm recording this video, I still don't know when those office hours are going to be. But you can either send me an email or attend my office hours, and I can help you out with that main trunk resistor circuit worksheet. Okay? Well, thank you very much. I need to figure out how to stop this recording. Here we go. All right, thanks.